turn it over.
Sounds good. Thank you very much, Annie. Really appreciate being here again. This is the third time, and just every single time it's been great. And then I've been there in person as well, I think 2 to 3 times as well. So it's been always a great working relationship between the Pelham Public Library and myself, as well as we have the Pelham Public Library too, as well. I do believe maybe a few from there that are maybe in the crowd today, or will be at least watching this on YouTube afterwards. So very much happy to be working with 2 libraries this time. And yeah, today's program is different than my storm chasing show, different than my bird programming, although there is some storm stuff in it because of course we see storms at night as well too, but very much looking forward to sharing you kind of a different night sky program. And before I forget, you can check it out after, but I'm going to make sure I enter it now. I have some websites that I put in the chat. I will read them out loud for everyone as well too, just in case you have a hard time accessing the chat, but I will do that after the show as well, kind of give you time to think about questions between the actual presentation as well as the question period itself. So without further ado, I will get started here. And I'm basically going to start you off with kind of a fairly local landmark here of Balls Falls, and this is in the moonlight. And yeah, just going to take you from daytime to the night sky. So often I like to start at twilight time when I'm doing night sky photography, because of the fact that it kind of just allows you to work your settings on your camera into the night as well. You kind of walk them along as you adjust to make your camera more sensitive in that. And also twilight just adds a neat light to the overall sky. You can see how it affects the clouds there, and just kind of gives it that well, the end of day glow. And of course, the first thing we got to cover is the biggest, most impressive thing to us on Earth here is the moon. And what you're looking at is craters. There's some of the larger craters like Tycho. And then of course we have the lakes as well too, where they're actually frozen. But you can see the gray areas, those are very large lakes. And then west to east, it's odd to I never used to look at the moon and go, oh, that's the west side and the east side, but I do now after setting up that chart. Now, as for Smoky Skies, they can add a really neat look to the overall look of the moon too. So generally every mid to late summer, we have that. And then watching the moon come up above the horizon, even in the winter as well as in the summer, you can see it kind of get stretched out. And that's because of the layers being thicker at the horizon when you're looking through all the layers. So it distorts the moon a little bit more as well. And then there's the supermoon. So the supermoon, what is that basically? Well, the supermoon is something that you generally see once a year because it's the largest moon, and it's about 13% larger than the other moons that you see throughout the year. So that's just optical. Obviously, the moon doesn't change in size, but overall, it does. If you're a photographer, it does give you a greater chance just to have it a little bit larger, and that can help make a difference between a photo being 16 by 20 or say 18 by 24. So it can make a little bit of a difference that way. I also like the moon at sunrise as well as sunset because you can get different cloud cover with it. So when it's a waxing moon, you see it coming up in the twilight sky, or actually it's going down. And then you have the waning moon, which is near the end of its cycle. And then it's basically, you see it kind of in that crescent phase. Always beautiful to photograph or just look at that time, especially when sunrise and sunset colors are involved. Then we have the lunar eclipse. So I always enjoy lunar eclipses because of the fact that it changes to that kind of real dark red look to them, as well as the fact that you can start to really see different features on the moon. It gives you a different, almost like a different lens as it happens, a different look through a different colored lens, basically. Then you have here the partial solar eclipse, so the moon between us and the sun. So there's bites there, but I think it's 2024 that we actually get to see the full eclipse, and it's prime for the Niagara region, and that you actually live right in the prime area. Buffalo is kind of the prime zone, so as you know, not very far away from that. And then one of the things I enjoy about the moon is the fact you can get these big halos around it. So this is often in the fall, summer, or I mean fall, winter, and spring. Sometimes in the summer though too, where you get this high cirrus cloud. And I like to look at the moon with these rings around it at night because of the fact you can look directly at the moon. They happen around the sun as well too. It's a solar halo, but of course you can't look directly at the sun. So I always enjoy the ones around the moon. This is actually taken right in Beamsville, and you can see that ring. And sometimes you get a little bit of a hint of red on the inside. And the more uniform the cirrus cloud is, the high thin cloud, the more prominent the color is. Whereas you see this cloud's a little rougher, but you can see the color is actually closer to the moon. That is what's called a corona. So when you have that corona around it, it kind of looks more like a halo effect, but it's actually completely almost attached to this, to the moon itself, or even the sun. I've seen them during the day as well too. Now, when the cloud becomes heavier or thicker, you can still see some of the coloration around it, but overall you don't get that circular effect around it, the whole kind of, almost a halo effect or the aura around it. So that's what can happen too. That's just because the ice crystals aren't as even as what you're seeing here when it comes to the halo itself. You can just see it on the right side. And you'll notice as the clouds get thicker, you can see it almost, it looks like it's shattering at times. That's how it can have that appearance to it. And that's when you kind of, you can tell that usually it means there's a system actually pushing in, a weather system, and precipitation's usually less than 12 to or between 12 and 24 hours away. But here's another picture. There's the corona. So you can see how much closer to the moon it is. Whereas when it's the moon and the halo, that's about 22 degrees away from the moon itself too. You get some other neat things like moon bows as well. And sometimes you'll pick up just a hint of color on the inside, usually just a shade of red that you'll pick up on it. But if you have a foggy field, if you live in an open country, or the Pelham area is good for it out in the country, you can get these moon bows that will form as well. Now, as for some of the neat things you can get with it, see these rays coming from behind the moon? This is a thunderstorm that was actually pushing through the Welland area at the time. I was in Beamsville looking south at it, and you could see the moon rays coming behind, so the crepuscular rays and that. So depending on the orientation of the storm and how 3/4 maybe to full moon the moon is at the time, you get these beautiful rays that come out from behind it as well too. And the larger the moon, or the more full the moon is, the more prominent those rays are too, because of course there's more light to work with. Now when it comes to the shifting light, sometimes you have nights where there's nothing else happening. So what I'll do is I'll go to the woods, set up the camera, and just kind of show the landscape change. You can see as the Earth rotates, the moonlight shifts, and you can see the shadows kind of walk along there. And that's Beamer Falls and Grimsby there as well. So it's the moonlight just kind of adds a magical touch to the landscape, kind of like what you're seeing here with the escarpment as well. So that was the Beaver Valley up towards the Owen Sound, Meaford area, Georgian Bay, whereas this is Grimsby looking towards Niagara Falls. Niagara Falls would be just off to the center right there. And I use the moonlight just to kind of balance out the sky. Obviously in this scene, there's not as much light pollution, so it's easier to do so. But even in the pollution, the light pollution, and that, I tend to try to balance out the sky as well with it. So using the moon just gives that little extra touch of light. Now, when it comes to northern lights, they tend to dull the appearance of them to your eyes, but they still can be seen until if you get some cloud that decides to push in and kind of block everything out, which unfortunately I'd say we lose about 40% of our northern light displays in southern Ontario due to cloud. One that actually happened, I think it was on just about 3 or 4 nights ago, that again, it was cloud cover. This is a super moon. You see the northern lights actually over Toronto. There's Toronto just on the horizon, so they can be seen from down here, but the super moon is really washing that out. So the super moon has its pros, but if you want to see the northern lights, you have to actually be quite a bit further north to see them with the super moon at the same time, because it tends to just dull them out too much unless it's a very, very strong northern light display, which I will touch on more again as I get into this program. Now, as for Toronto, just itself, you can see the difference with light pollution. This is Goderich, but you can see how much it affects the sky. So Toronto itself, being south of Toronto, does really kind of eliminate a lot of these stars that we would typically see otherwise, whereas this is actually looking south towards Lake Erie, so Welland would be off to the left here. And so it really does allow you to kind of not only see more, but also use your camera settings to pick up more as well too. So you can see that pushing through here. We have the moonlight. what I use moonlight when it comes to weather for is to analyze what's going on with the sky. You can see the cloud fill in quickly and then it dissipated really quickly too. So it's a kind of a health check on it. And I do look for snowy owls in the moonlight as well too. I like a good challenge, and I found this one night and sitting on a power pole, and then therefore I did a time lapse of it. You can see the stars moving in the background. What was neat about it was looking. You can see the owl looking around and scanning the fields. And what you can really tell here is look at the pupils, how large the pupils were. I didn't shine a light on it to focus it or anything. I just used the hydro pole to focus on. Now, as for here, did you see that kind of go up quickly there? It kind of looked like a quick airplane, but it disappeared. That is actually the Minotaur space rocket. And this is Crystal Beach. And that, although a lot less water there at that time compared to what I've seen recently. Now, the neat part about it is, you'll see it here again, is the fact that that's visible from 885 kilometers away. That's Wallops Island, Virginia. And it took about 2 minutes after the launch for us to actually see it. So some really neat things when it comes to that. We're one of the few areas in Canada that can actually see their launches, the Minotaur space launches from Wallops Island there. So it is worth keeping an eye out for the forecast to be clear, as well as for when those launches take place, which is usually on average, I'd say about once a year almost, not quite once a year. Now we're going to take a look at lightning here. And lightning is what basically got me into photography. It was lightning, northern lights, and oddly enough, wildflowers like the trillium you heard in the introduction there. That was purely more so I needed something to sit there because northern lights and storms are always running away from you. And so you can see here, basically how lightning forms is you have a very large cumulonimbus cloud, so a large thunderhead, and as it updrafts, it enters colder air but continues upwards. Well, as that happens, you start to get ice crystals, snowflakes, and other things like that. So it starts to build up a negative and positive charge. The negative charge goes to the bottom of the cloud, and the positive goes to the upper part of the cloud. So as the storm builds, you start to get an imbalance with the ground as well as the cloud. So what can start to happen is you get a step leader that moves its way down towards the ground, and then positive streamers come up to meet it. And then when they connect, that's when, of course, we see the big flash or maybe the multiple strikes. What's fascinating about lightning is the fact that it's going through that cloud right now, and any water droplets that were in front of it there, or that it passed through, would just evaporate, because the lightning can actually be up to 5 times hotter than the surface of the sun. So that gives you an idea of why, you know, if you are struck by lightning, it often leaves victims burnt because of just how hot it can be. The night sky, when it comes to lightning, really does kind of give you a whole other view of what's going on. The clouds look so much more dramatic, and you'll see some of that, and some of them from our local area as well too. It also can give you a nice view of what this is here towards Grimsby, where you have upward lightning. You can see the upward lightning go up and across. Now that's usually triggered by a nearby cloud to ground lightning strike, and then it triggers an upward lightning strike. They are more rare. Oddly enough, they are more common, I find, in Ontario to be in the fall, and rarely in the winter because lightning is rare itself, and then in the spring as well. And then in this exposure here, this is towards the Hamilton area, and you're going to see how the lightning beads. You're going to see the beads falling, and what's neat about that is it's actually a natural fertilizer because that's nitrates falling, and it's caused by the lightning being so hot it turns the nitrogen into the air as nitrates and then falls down to the ground and then hopefully into your garden and surrounding vegetation and helps things grow. Now, as for power going out at night, one of the neat things about it, we are one of the few storm chase teams that do chase at night, and it allows us to see things again quite differently. So this is a rotating wall cloud. So it's a supercell thunderstorm, which means rotating thunderstorm. Now, at night, obviously, visibility is quite a bit more limited, but as you see here, there's little telltale signs about what could be going on in a storm without having to look at radar or being able to see much. You're going to see a random power flash here in a moment. And usually if you have a power flash, but it's caused by lightning, you'll see the lightning first and then the power flash. That tells you that was caused by lightning. But if you get a power flash, but there was no lightning before it, that doesn't mean that it was that it's a tornado, but it does at least mean that there's strong winds in the area. And we've never got a tornado at night, but this is over Lake Erie. And my dad photographed that particular water spout. So they do happen at night, and tornadoes do happen here at night as well too. It's just fortunately they're not that common, because nighttime tornadoes are not that enjoyable. Although last year there was one in Port Colborne that hit around 10:15 in the evening, and so that was it was small, fortunately, but definitely very local for both of our areas. Now, stratiform lightning is one of those spectacular lightning strikes you'll see. It's usually when a storm is actually starting to decay. I find it best to look at it at night because of the fact you get to see just the lightning go from one end of the sky to the other. So this is near Stony Creek, and you can just see my camera at that point was only catching parts of it. Very little of it was actually in the frame because it was just going from one horizon to the other. You may recognize this. This is the QEW heading towards Fort Erie. So oftentimes, especially with living in Welland, you may look towards your south and then see these big billowing clouds at night, and then lightning striking inside them or flashing inside of them. And it can be quite frequent when it does get going, especially in the months of July and August. That's when I tend to enjoy watching them because of the fact that lightning gets quite intense. Now this is Cayuga area. See how the cloud is moving to left to right? And then all of a sudden it turns kind of right to left there. It shifted. So we had, what happens in both of our areas quite a bit is we get northeast winds that are coming off of Lake Ontario. And then we may have an approaching storm coming from the west. And then when that storm comes, it pushes the cloud that were coming out of the northeast and shifts it back to the east as well too. Then Fort Erie, here's a great example of it as well. Lake Erie is just one of those areas that storms that, if the conditions are right, they can be sparking there for hours, especially if the winds are converging. So again, living in the Welland area, the Pelham area, it gives you ample opportunities to see storms like this off in the distance. This one here, for example, was over Crystal Beach, and you're actually seeing the lightning come outside of the storm here. That's called bolt from the blue lightning. You saw some reach into the air. That's cloud to air lightning, which is the weakest form of lightning. And then in the last frame here, again, you'll see this lightning kind of coming right outside of the storm. And then that airliner actually flew around that storm as well as it came out of Buffalo. So again, it's one of the most spectacular sights I find is just seeing a distant thunderhead with lightning going almost every 1 to 2 seconds. And then if you get a line of them, it's like they're communicating back and forth, and that too. It's often referred to as heat lightning as well. So the term heat lightning doesn't really exist in the way that we think it does, because all lightning does produce heat. Now, there is some lightning that we don't hear thunder with. It's because of the fact there is thunder with it. It's just that it's intra-cloud lightning. It can be very small, so the sound waves don't reach you at the surface. Another reason why you can have it is the storm can be off in the distance, and that's why you won't be hearing the thunder with it as well too, because of the fact that it's just too far away. So that's often the reasons why, you know, if you've ever heard the term heat lightning, it's usually even on a hot summer's night. So it's understandable that that term was created, but all lightning does have thunder. Like I said, it's just the fact that it doesn't necessarily have enough punch to it to actually reach the ground, especially because 80% of all our lightning's inside the cloud. So here's utilizing the moonlight with a storm over Milton at this point, and I'm at Beamer Point. And so again, utilizing the moon to see the storm's health. That's one thing we will do at night. So for you, you're not a storm chaser, so you can just enjoy the view of the cloud structure along with the beautiful lightning below it. All you have to do is make sure that when you start to hear thunder, that you need to go indoors, because it can actually reach up to 5, 10, 20 kilometers away from a storm plus, which is why they say wait a half an hour before you go back outside after the last rumble of thunder. And so here again, just more proof over Lake Erie that you can get those really interesting lines that form over the lake, and they'll just keep training up the whole lake the entire night. I'm sure many of you, especially that live in Welland or have a view to the south from Pelham, you've probably seen them where they just keep marching across and across all the entire, almost what feels like the entire night there. And yeah, so that is the kind of the lightning aspect. Now we're going to take a look at the gust front aspect. So again, light pollution is kind of one of those things where if I was just photographing stars and the Milky Way and things like that, it would drive me nuts. But in this particular case, I actually like to utilize the lights of Toronto. There's the lights of Smithville to see again the clouds' health, see some of the dramatics that are going on. So in this one, you're going to see a roll cloud cut across the horizon here. And again, I used the lights of Guelph in that particular case to see what exactly was going on. And I will do that again in the next clip here from the Brantford area, because this one's a much slower moving one. So what is a roll cloud? So a roll cloud is basically when a storm collapses and then it gusts out, and that's a part of the weakening process. And it gusts out, and the technical term is outflow boundary, but as you can see here, it looks more like a roll cloud, and it's rising on the front, and then you have the cold air sinking on the back. Warm, moist air on the front, cold, sinking air on the back. So if you ever see one of those at night, you don't have to, some people kind of look at it and think the world is ending. It is generally harmless, especially if it's detached itself from the storm. You may feel a little bit of a breeze with it. Sometimes you'll actually hear the wind hitting the tops of the trees, yet you won't feel any wind at the surface. It's kind of an eerie feeling, but it's really neat at the same time. And then again, utilizing the lights of Hamilton here to kind of show this gust front. Now, this gust front was actually because of a convergence area. You had southwesterly winds hitting northwesterly winds. So you could kind of see the cloud just kind of stalling there a bit in the time lapse, and very little precipitation with it. And this can actually happen into the winter quite a bit. These types of clouds are more rare at that time of year, as are thunderstorms, but you can actually see them into the winter. And Hamilton, I seem to see one or two of them over Hamilton every winter, which again, an odd time of year to be seeing gust fronts and shelf clouds and other features like that. So again, we head back to Lake Erie, keeps us nice and local here. And same with Brantford too, but you can really see, utilizing the town lights, just how stacked some of these shelf clouds are. And that, so the more layers they have, the more severe they are. So this is utilizing the city lights to highlight that. And so for example, a storm chaser, we're out there, and again, we're just seeing how low to the ground it is, as well as radar information. Sometimes you can have the rare one that comes in that's kind of really beastly looking, and then it comes in with a whimper of wind. Most of the time, though, they have some pretty good strong winds with them, again, followed by heavy precipitation. But the lightning aspect just gives you a whole other depth to it as well. So here's your kind of shelf feature, and see that cloud above in the middle there? That is actually rotating. So you can really kind of see this almost like a rotating staircase there with the clouds. So again, the term supercell means rotating thunderstorm. Fortunately, only 90% of the, or 90% of them don't produce tornadoes, and that, but 10% of them still do, which is still a pretty high percentage, but it's a lot better than say 50-50. Now to move on to another reason I got into photography, and one thing I love sharing with crowds, is northern lights, because it's something you can enjoy as well too, and they can be seen from the Welland area. It's obviously a little bit better if you just live north of the city, but they have been seen right downtown Toronto before. Very rare, generally once every, I'd say, 10 years and 11 years basically, and so therefore it is trickier. Now, how do northern lights form? Well, they originate from the sun. They start off usually from a sunspot, and then what happens is you have a solar flare and / coronal mass ejection. So the solar flare emits electrons and protons. So you get a proton rush basically with it. Whereas it's the CME, the coronal mass ejection, that's what it launches out plasma. And as that plasma, if it's Earth directed, that enters our interplanetary magnetic field, the IMF, so it goes into our upper parts of our atmosphere. Now there's a defense mechanism that the Earth has too, and that's where it can actually go north and shield us from that incoming plasma and radiation, and then the energy goes around it. That's what often fools a lot of people when it comes to the forecast. So the northern lights are forecasted to be seen all across Canada tonight, but then that last minute shield kind of puts the energy around us. But when it tilts south and lets that energy into the atmosphere, it can be really quite spectacular, like the northern lights you're seeing here in the background. Now the rating system for it, well, actually I'll touch on sunspots first, and then I'll get into the rating system of how the storms are rated. So this looks like a giant sunspot. It's actually or solar eclipse at the time. But the sunspots, fortunately, are much smaller, are actually what you can see on the edge right there, just above the tree line there. And so sometimes basically the average size of the sunspots are Earth size, so maybe 1 or 2 Earths. But some of the larger sunspots can actually be 8, 10, even 13 Jupiters wide. And those are the ones that create monster corona mass ejections / solar flares. So most solar flares are weak and they're in the A to B range. C range will give us northern lights if it does head towards Earth up into the Arctic area. Sometimes they get down here, but generally those are northern. But the M class flares and X class flares, which we're going to be hearing more about over the next 3, 4, 5 years, because of the fact we're going back into the peak of the solar cycle, which is 11 years in length. That's when we start to get into the big displays. So we actually had an X1 recently that they thought was going to head towards Earth, but it actually ended up going around. It missed us. Then we had an M1 flare that actually hit, and it was big. It was actually quite large. So it was really fascinating on the anticipation of the one, and the forecast kind of missed it, whereas the M, which was a smaller flare but hit directly, that actually gave us a really, really nice display. So if you're, say, for example, I give you the website today, spaceweather.com. Again, it's in the chat, and I will read them again at the end. If you hear of a northern light display, what you'll often get with them is a range of worded forecasts of where they can be seen. Now, they don't forecast for Canada on spaceweather.com, but if you are reading about states like New York, Ohio, and Michigan, then you stand a good chance of seeing the northern lights. They'll be a little bit faint, but if you start to read about Kentucky, Virginia, and then central states towards Kansas, even northern California, which saw them 3 or 4 nights ago as well, that's when you know you're in for a very, very spectacular display. How they form. Now, a lot of times you'll see a dull glow to the north. This is called a halo or an arc. You can just faintly see it in there. The moon doesn't help at this point too, but watch what happens. It will actually burst into what's called a solar or an aurora substorm. And then when that substorm hits, that's when it erupts. So sometimes you have to be very, very patient and wait for that halo to break apart. Now, I've photographed around 200 displays in southern Ontario, as well as some in northern Ontario. And I've only ever had 2 halos not break into a beautiful array of curtains. So it's very rare for that not to happen while you're watching them. So if you see that dull glow, just wait a little longer. It can sometimes be 5 minutes later, or sometimes it has to be an hour or so, but it should burst into these beautiful rays and curtains, similar to what you're seeing on the screen here. Now, to give you an idea of intensity, so you'll see a rating system of what's called minor storm to G5. Minor storm is like a G0, and then you have G1 through G5. For us to see them down in the Niagara region and see them really well, I find it's a geomagnetic storm 3. Now, I've seen them at 1 and 2 level, but you have to know they're there, and they generally start to kind of blend in with the lights of Toronto as well too. So it's not really all that spectacular to look at. But if you ever hear about a G3 to G4 and G5 storm, that is when you'll see the northern lights in the Welland area as well too, especially if they've hit in the evening time. I find that tends to bring the auroras closer to us and they're higher up on the horizon. So this is a G4 storm that you're looking at right here. So this was on Georgian Bay. Now it was starting to retreat at this point. So the earlier scenes you were seeing there was actually a better example of that. Now this here you're seeing in the moonlight, this is up in the Huntsville area, and this wasn't even a G1. This was a G, or the minor storm aspect. So that really gives you an idea that further north you go, you can see them at a weaker level, even with a supermoon at the time. This here I like to show because bloopers happen. As the northern lights got in towards their substorm, it then got blurred out because my lens got foggy, whereas my dad was just a few feet up higher, his lens was fine. But I still find it a funny clip, even though at the time I didn't find it as amusing. And then you can see here northern lights in the background. So this is a weaker display with the lights of Toronto there as well too. And watch the left side of your screen. You'll see a very quick blip of rays right in the light. So it's very, very hard to see. and then dawn will also take out the northern light displays too. But I'm sure all of you know about this ship on the QEW there at Jordan Harbor, and so this is a G3 level storm, and you can see the northern lights dancing in the background, and then the lights of Toronto off to the left there as well too. So like I said, it can be seen from this area. I use this as a landmark to make sure that people realize just how local they can be. And you can see them dancing in the background. I find that you have more purples in the springtime and then more of the reds in the fall time. I actually nicknamed October Red October for auroras as well too, because of the fact that's often the color you'll see above the green at that time of year. Now, as for northern lights and lightning, I've only ever seen that twice in my lifetime, once in 2003. I thought it was more common than it was, so I actually focused more on the lightning, which then finally in 2018, I photographed the northern lights again with lightning in the background. And that too, this was over Lake Huron. So twice in 21 years. If I'd known how rare that was back in 2003, I certainly would have focused more on combining the two, but that was pretty early on in my career. And then there's what's called a secondary aurora as well too, or a secondary substorm. So you can actually see the northern lights here. To the eye, they're not as strong, and therefore they're not as impressive, but they're neat because look at this here all out by itself. So we have the northern lights to the north, like what you're seeing here, but then you have a secondary subaurora arc as well too. And that's when you know that you've got a pretty impressive display going on. And whenever you can have a pond or a lake or anything between you and the northern lights to cast a reflection, it just makes it that much more richer because of course you're getting basically double the image as well. So if you do have a chance to go up north, some of the best locations, if you could do a flight or a trip, would be say Whitehorse, Yellowknife, Churchill. Newfoundland's pretty good too, but they battle a lot of cloud out there, whereas Yellowknife and Churchill tend to have, especially during the fall and winter, tend to have more of the clearer skies basically as well. And like I said, they can be seen right through until dawn. Usually dawn cuts it off, whereas the northern lights are actually still there, just we can't see them due to the brightness of the day coming along. And yeah, you've seen this too here with the Milky Way as well as the northern lights. We're going to move into the Milky Way part of our program here. Lots of really interesting facts when it comes to the Milky Way. So with the Milky Way, it's actually 13 billion years of age, and we are inside it. We are 26,000 light years away from the galactic center. So when I say light years, it sounds like it's time, but actually 1 light year equals 9.5 trillion kilometers. So it kind of gives you an idea on just how large this is. And then to get a bit more of a breakdown, the Milky Way, or our solar system, is only 0.0019 light years in distance. So it really gives you that idea that we are quite small when you look at the overall universe that we are in. And then the Milky Way itself, visible wise, you really want to be in dark skies for it. And it takes up about 30 degrees of the sky. I find about mid-spring till about mid-fall, and then any time in between that, it is quite spectacular to look at because of the fact that it's all in full view. Now, clearer nights are better, so less humidity, you'll have a better look at it as well too. And it was actually Galileo in 1610 that discovered that it's not just a bunch of cloud and dust, it is actually individual stars and planets. So for stars, there could be as many as 100 to 400 billion different stars inside the Milky Way, as well as another 100 billion planets. So it really, again, it just shows you how vast space is. And what's really fascinating about it is we see a lot of the stars and it's all kind of 2D. But when you actually take a look at galaxies themselves, like the Milky Way here, it makes up for about 90% of it is actually dark matter. So it's all just empty, kind of empty space as well. So really quite some neat things when it comes to that. I just enjoy the view of it, and then combining it with also the stars and thunderstorms off in the distance. And this is not far from you as well. This is Morgan's Point. And I like to look south there towards it. And yes, you do get the city lights as well with it, but still you get a nice view of what is actually taking place above that. Now, as for chemical compositions of meteors, they tend to be magnesium if they kind of have a green tint. So you can see that here, a bit of magnesium in it. There's also some calcium, a little bit of purple in it as well. And then if you see orange, that's more of a sodium rich meteor. And then iron is yellow, and then red is your nitrogen and oxygen. So that kind of gives you an idea of exactly what's their makeup is at that particular time. Now, when it comes to the meteor showers, my favorite one is the Perseid meteor shower because of the fact it's also the warmer time of year. You can be outside and you don't have to be bundling up. Although one time I was on the Bruce Peninsula and I remember seeing 5 degrees Celsius on the temperature gauge on my vehicle. And I go, is this August or is this October? And but it was worth it when it came to the dark skies. Now, another good one is the Geminid meteor shower, which is actually coming up in December. It's generally around the kind of the 11th to 13th area of the month. And it is actually can be even more impressive than the Perseid meteor shower because there can actually be as many as 100 per hour, sometimes 100 plus. And I find there's a little bit more fireballs with it, so your larger ones. So fireballs are the ones that they can enter the atmosphere, is very rare, and then get down to the Earth's surface. But overall, most of them actually just burn up in the atmosphere. And some of the neat things about them is their ranges in speed can actually be between 11 kilometers a second to 72 kilometers a second. That's why they kind of go in a quick blip. So to give you an idea, that's about 400 or 40,000 kilometers an hour, as well as can be up to speeds of over 200,000 kilometers an hour. Now, this is actually taken again from Lake Erie, just south, and again, Morgan's Point there. And you're going to get to see something really neat here. You saw that dust kind of fly off it there. I'll put it into slow motion here so you can see it. But that's an impact there. So that one had a little bit more substance to it. And you could actually see as the time lapse went on, that kind of cloud of dust that went along with it too. So it just always keep an eye out for that, especially if you're utilizing a camera. I, for example, run time lapses, which allowed me to catch that dust and how it kind of dissipated afterwards. So if you're just firing your camera over and over again, it can be pretty neat to watch. I've never actually seen the dust with my eyes, but then again, I'm constantly looking all around the sky. So therefore, I'm not really focusing on the last impact. So that might be something I'll try to do in the future because I'm not quite sure if it's visible to my eye. I'm guessing it's not, but it's still worth checking because you can see that impact there. What's neat about that type of cloud is the fact that it can actually form what's called, or I should say dust and debris, is they believe that it actually creates a type of cloud called Noctilucent Cloud. And it forms at the 80-kilometer level above the Earth's surface and has a real electric look to it. But right around twilight time, usually about a half an hour to 45 minutes after. We rarely see it down here, but in 2019 in June, it was seen down here. So it is something that you can see. It's just, again, very rare, generally the further towards the mid-latitudes and lower latitudes you go. And yeah, so a meteorite is much smaller rocks or particles in orbit around the sun. And then you have the actual meteor. If a meteoroid enters the Earth's atmosphere and vaporizes, it becomes a meteor, which is often called a shooting star. And then a meteorite is one that hits the Earth's surface without burning up. So that's why they'll often be looking for them in the Arctic regions, because they'll sit on top of the snow, or snow will melt and show up past meteorites that have reached the surface. There are some frustrating nights out there too. There's strike one. So even on peak nights or near peak nights, because if cloud took out the peak night, you sometimes just don't get to see many, especially when it's around minus 20 degrees as well. That's when you go, oh, that strike really hurt, because you're generally feeling it at the fingertips as well too. But most of the time you will get rewarded. And even in August, like I said, with the Perseid meteor shower, it is something that you can enjoy because of the fact it's generally a warm summer's night. And I find it's after midnight is when the numbers start to pick up, and best before dawn, about an hour and a half before dawn, especially during the Perseid meteor shower, that things get really, really active. and that, whereas I find the Geminid meteor shower, I found it to be between 12 and 3 in the night, to be more active at that point as well too. And like I said, they generally vary from year to year, where sometimes you have maybe 60 an hour, sometimes it's a bit over 100. And then of course light pollution cuts down the number, but fireballs are still quite impressive at that time. You're actually going to see a fireball come on screen here, there. You can see that cut through the sky there. So, and then we have comets. So comets here, they're really neat in the way that they're hard to see with the eye. Comet Izon was pretty good when it came to that aspect. And so what is a comet? Well, a comet is basically, it's warm enough, it creates an extended tail, gas-rich cloud known as a coma around its nucleus. So that's what you often will see, especially in photographs where it's a really long tail. And it contains often carbon, nitrogen, and carbon bonds, and the sun's ultraviolet light, which will excite the electrons, and that's what you get to see when it comes to the big tail. So to give you an idea, Comet Lovejoy reached around perihelion. It reached its max closeness to the sun on December 16th, 2011, and it was about 140,000 kilometers away from it. So it really gives you an idea how close it was, which is why it had such a tail to it as well too. And yeah, so that's, comets, I've seen them from the Niagara region as well. Again, light pollution plays a bit of havoc with you, but overall you still get to see a nice view of them, especially the darker sky you can get, and even better with a camera or binoculars. Now you're just looking at a moon pillar. Now you're looking at light pillars. I have seen them in the Niagara region as well too, more rare than further north, because both Lake Erie and Lake Ontario kind of have a moderating effect, so it often melts the flat horizontal ice crystals that are falling through the air, and then they dissipate before they reach the light. Sometimes you can see them up higher though as well, and so they're not completely attached to the ground like what you're seeing here. But overall, I have seen them down here, and they can be really spectacular. And up on the escarpment is actually more favorable for them as well too. So when I say up on the escarpment, basically Smithville across to Pelham is probably more favorable than where I live in Beamsville, as well as Welland, because again, Lake Erie can have an effect, even seems to have an effect when it's frozen as well too. So it just has this moderating effect overall. But you can see the ship there, and then couple pillars in the background as they disappeared over St. Catharines, because as the heavier frost got in, there was too much that the lights weren't able to actually refract the same way. Because they're often referred to as man-made auroras, but they don't move around because of course the lights are fixed, unless you have a car driving down the road. That can look pretty neat as well too. And then we have fall streak holes. So again, utilizing the ship here, I was actually photographing the Geminid meteor shower at the time. There wasn't much going on that way, so I focused on what are called fall streak holes, or hole punch clouds. And they're the best I find in December towards the months of March. So all between December and March. But I've seen them at any time of year except for the month of July. So you can enjoy them in warmer times as well too. It's just not very common. Now, this is a neat night sky phenomena that not many people know about, but this is the city of Toronto. And note how in the background here, all the buildings look to be at the same level. Even the sky, or sky dome, I still call it that, the Rogers Center is flipped over. You can see a bit of a U shape there of the refraction of the light. This is what's called a superior mirage. So a superior mirage happens much different compared to the inferior mirage. So the inferior mirage is the one that you see when you're driving down the road and it's a clear day like today and the sun's heating up the pavement, and then you get kind of what looks like a puddle up ahead, but it's just a refraction of the sky downwards and then back to you as the viewer, because of course as you drive there the angle changes and you don't see the puddle there anymore. That is your typical inferior mirage. Whereas a superior mirage is the reverse effect. So the pavement is warm in an inferior mirage. The lake here is cold. So what happens is you actually get the refraction going upwards instead. So for example, we're going to show you an inferior mirage first. This is actually Lake Ontario, and you can see the lights are kind of in the lake. It looks like it's in the lake, and you can actually see the image where the cars will be driving out. Press play, and you can see kind of the lights off in the distance. So that's being projected downwards. That's your inferior mirage. Now we're going to take a look at the superior mirage, and you can see Toronto here off in the distance, and the buildings kind of look like they're hovering. It has a very futuristic city look to it. So you can see again the buildings kind of, and that is basically, you have the cold air at the surface. Lake Ontario is like a big cold bathtub, and then you have warm air above. And naturally, warm air wants to push up through cold air. So when the cold air is trapped at the surface, you have the warm air above and not much movement. You need calm winds for this to take place as well, too. And so it just gives you this really wild looking sight. And then this is up towards the Oakville, or not Oakville, but Oshawa direction. And you actually see probably lights from the 401 being refracted at times, or maybe one of the cities there where the layer moves up and then back down. So you get a glimpse of it and then it changes. So it's just something that if you're looking at that, if you're looking at the view of Lake Ontario or even over Lake Erie, keep an eye out for a ship to be going along, and then have it looks like on top of it another ship but upside down. It's the same ship, but it's just the lights being refracted, so they travel along together. So it's really quite fascinating. I believe it was back in the 1890s that the conditions were so prevalent for that sort of thing that the mirage was actually seen from Buffalo of Toronto, and they could actually see Toronto up, it would look like up in the sky. So conditions can really become quite wild when it comes to that, and you can really see some spectacular things with it. So I will now close the presentation part down here, and we're going to open things up to the question period. You're welcome to ask your questions on camera, or you can also use the chat. And one good thing you can use is to raise your hand in the reactions below. But if you have a camera and you're not quite comfortable using the reactions, feel free to wave me down as well. I generally will see everybody. But first, I'll go through the some of the websites I use, and then that might give you time to think of some questions as well too. So, for example, my favorite Northern Lights website for basic, quick information and forecasting is spaceweather.com. It gives you written forecasts, but there's charts there as well too. Once you start to develop even more of an understanding, then you can utilize even Google other websites for Northern Light forecasting too. But space weather will get you started, and generally I find that's really all the information you need when it comes to that aspect. As for a weather website, windy.com is the one I would recommend. It's user-friendly. If you get too many layers on there or get lost in the layers, all you got to do is close it down and then go back into windy.com, and it starts you all over again. So you don't have to worry about pushing too many buttons in there. Like I said, you can automatically restart it by just even refreshing it, or at least closing it and starting it up again. And some Northern Light apps as well too. So two that I've heard are very, very good ones, because I actually don't really use them much. I usually just use spaceweather.com for all my information. Is Aurora Borealis Forecast and Alerts. That is one app, and it is available on both iOS as well as Android. And then there's My Forecast and Alerts. Oh, wait, I guess I copied that one twice. So that is the best app. That was the #1 rated one. Okay, it is a different one, but there you go too. So those are two that you can utilize for Northern Lights forecasting. Now, as for stargazing apps, again, these are free. Most of them have upgrades. Usually cost about $2.99 or less. But Starwalk is one that you can use. Actually, Starwalk 2. And then there's Star Tracker, and then Skyview Light. But if you want to explore, I often, for my weather and storm chasing, what I will do is I will often do a search each spring for new weather apps, just to see if there's anything out there that makes my job easier. So you can always do searches that way too, but these at least get you started and give you a good start to that sort of thing. So now for my favorite part of the presentation is the question period. Well, I'm curious to see if I've answered all your questions, or if you do have a few, but you're welcome to, like I said, ask me on the chat or on camera. It's always that first one that can be the tough one to get going. And then after that, oh, Kathy, I see your hand. Oh, just get you on mute there.
Okay, you're talking about space launches, that you can view
Yes.
the space launches. These are the space launches from where? Cape Canaveral?
This is the one from Wallops Island, Virginia. Yeah.
Oh, okay, that's why I was trying to find out. From
Good,
Walmart?
good. Yeah, Wallops
Walmart?
Island. It's WALL and then OPS and then Island. Yeah. Yeah, it's in Virginia. It's an Air Force base actually, and they generally do launch them, like I said, almost once every year. And their payload is usually consisting of satellites. And the one that you saw in the time lapse there, there was 28 satellites on that specific rocket, and so yeah, it's something that I really hope that, especially with where you live, that it is clear the next time they have a launch as well. And that's usually on spaceweather.com as well too. They'll put other information on there. And so that's, but yeah, it's really neat to see it. It takes I found about 1.5 to 2 minutes after the launch to finally get high enough that the angle was right for us to see it into the atmosphere. And but you visibly see it along, to the eye, it really just kind of looks like a distant airplane, just not one that's flying the most, the typical angle. But overall, it is something that you can't see with the naked eye if it's clear.
When is the specific, is there a specific time of year that they do this, or?
No, it's generally any time that they just have, I guess, the payload there as well. I'm kind of going to take a look here. I have the dates up. Yes, September, November, August, October. It seems to be at least the second half of the season. So I can at least say the second half of the year. And there are some years where they actually have launched as many as 5 of them in one year. So recent years there hasn't been as much action, but looks like, there is a bit of a, not prediction of the date, but in 2022, Minotaur rocket will be launched as well. So, and that is the U.S. Space Force base. So it will be the Virginia one. There's just, yeah,
Thank you.
Yeah, you're welcome. All right. Well.
Okay, can I ask another question then?
Sure, absolutely.
Well, you're talking about the winds. I'm going to switch direction now. The winds, I think you might have touched this a bit. How fast do the winds actually go, or what's the fastest that you can actually stay and do the photography of them before you get into trouble?
Yes, exactly. Well, generally, when the winds get closer to 100 kilometers an hour, we're kind of hunkered down at that point. Especially our cameras, especially doing nighttime time lapses. Sometimes when you're doing that, then you actually need winds to be kind of below 30 kilometers because it starts to rock the camera and your stars start to go back and forth with it. But we'll use trees kind of as protection as well as the vehicle at times to add a little extra protection. And yeah, as for windstorms in general, the one I'm sure you remember from last year, November 15th, there was actually winds that hit St. Catharines at 139 kilometers an hour, and then Crystal Beach and Welland area experienced winds over 100 as well too. So that's when we start to hunker down, and basically you're kind of holding the camera down, trying to keep it as stable, and try not to get hit by flying debris as well too.
Wow. Okay, I have another question then.
Sure, go ahead. Yes, absolutely.
When you're doing time lapses and you do these in a number of your pictures, how long does that time lapse encompass? Like, it looks like a long time, but I have no idea how long.
No, well, I'm glad you asked because yes, it is a long time. So I like to try to my time lapses as smooth as possible. So as much as sometimes 20 frames per second. So when you're standing out there for an hour and you're doing 30-second shutters speeds for each frame, you're only getting sometimes between 3 to 5 seconds, and that, so yes, most of the time lapses you were seeing there were probably 2 to 3 hours long, and that, so yeah, you don't necessarily need it that smooth, but I find it's more pleasant to the eye. And obviously sometimes especially the northern lights is if you have a stronger display, you can cut those down into half, so 15 seconds or 12 seconds, that gives you more frames. So sometimes I can get as many as 10 seconds out of an hour, and that feels a lot better. But yes, there are nights where things are maybe too dark and you want to really bring the stars out, and maybe even the weak northern lights, and you're sitting there and you're going, okay, this next hour is going to give me 3 to 5 seconds of footage. So, yeah.
Yeah.
Oh, good. We have a question here. And that on the topic of lightning, I've heard of a type of lightning called ball lightning. Oh, good. I always love talking about ball lightning. There seems to be some controversy as to whether it's real or not. Do you know anything about it? Is it real? If so, what is it and what causes it to behave the way it does? Also, have you seen it yourself? So I've personally not seen ball lightning myself. I only have one weird lightning photo where it kind of looks like a shooting star came out of the sky, but it was a thunderstorm at the time. So that's the only thing I could say that I picked up on camera that just wasn't like any other lightning photo that I have, which is well over 20,000 lightning photos now. So there's plenty of them to pick up on one that was just kind of strange. As for ball lightning, I do believe it exists. I think there's enough. I do believe there's enough eyewitness accounts. And like I said, I haven't seen it before, but I've actually went through different presentations and had different crowds, and people describe it the same way as how they've seen it. And so there's seems to be almost two different types of ball lightning, if it does exist, and where it exists. And one is that it's electrically charged hail. So the stories I've heard before are ones of kind of lightning bouncing down the road. So there's a theory that it can be a lot of kind of ice together, so a big hail chunk, and it just kind of bounces down the road, and then eventually the charge dissipates. Then there's another one where it's more like St. Elmo's fire, which it can be experienced in aircrafts where electricity builds up on the kind of the fuselage, and you'll get these little sparks, and they kind of have a blue light to them. Well, I've heard this from in 2 different locations where somebody said that actually passed into their bedroom, and then through the wall, and they watched it just float across and go out the other side. So, and that was 2 different stories, not necessarily the bedroom, but 2 different stories of that happening. So I really do believe it exists. I've seen potential video of it on YouTube. You can look up ball lightning on YouTube and maybe have a look at it too. The problem is with it, it's a light source, and if you have low light, the cameras tend to really expose distant things off in the distance as well, which can give it an aura look as well too. And even being slightly out of focus can also give it that aura look too. So there's still, I'm not really sure what we're going to be able to do to fine tune that. Yes, ball lightning really does exist, but I really, from what I can tell from the stories I've heard, as well as the logic behind it, I really do believe that in some way or form, ball lightning does exist. There's been too many eyewitness accounts for it not to exist. We just haven't caught it necessarily on camera yet. But excellent question. Thank you for that as well. Oh, you're welcome.
So anyone have any more questions for David? Those were some good questions.
Absolutely.
Yeah. Okay, well, I guess that's it then. So thanks everyone for joining us. And thanks again, David, for coming this afternoon. That was a great presentation. And yeah, bye-bye.
Oh, thank you for having me. Absolute pleasure. I love the question period, as well as I just love being local too, being able to refer to local aspects and talk about Lake Erie, which is right on your doorstep kind of thing.
Yes,
and so, yeah. So yeah, thank you for having me. And I look forward to being there virtually again sometime, or maybe
Yes,
even in
sure.
person.
Yes, that would be great too. Okay, so everybody have a good afternoon.
Take care, everyone.
Yeah, bye-bye.
Well, definitely.
Annie, are you still there?
I am.
Did you have any luck contacting about the gentleman about calligraphy?
I haven't yet because I was off Friday. I'll have to do it on Monday.
Okay, hot dog. I just wondered whether you had any response from them.
Yeah.
I haven't seen them again since, so if I see them, I'll let them know.
Okay.
Hot dog. Thanks again for this one, Annie. Ciao, ciao.